Now that we know everything about trig ratios, sine, cosine, and tangent, using trig ratios to solve equations, and inverse trig, we're going to apply that knowledge to word problems. So today we're going to start with angles of elevation. The angle of elevation is when you are looking up at an object, the angle you form with your new line of sight and a horizontal line. It's very important to point out that the angle of elevation is always formed with a horizontal line. So if we look at our picture below, here's our angle of elevation. It is being formed with this horizontal line here and the diagonal line of the person looking up to the airplane. So it's always formed between a horizontal line and a diagonal line. As you can see, if we drop a vertical line from the airplane to the pink highlighted horizontal line, we form a right triangle. So all these problems again are going to have to do with right triangles, except we're going to have to set up the problems ourselves. So let's just note that the angle is always formed with a horizontal line. So an example, if we look at the picture to the left, the person standing on top of the building is looking out straight forward. If that person looks straight forward, his line of sight is the pink highlighted line. The pink highlighted line, which is our horizontal line. So sometimes this horizontal line will be a person's natural line of sight looking forward. Another example of our horizontal line that will be formed, that will help form the angle of elevation, could be the ground. So if you are attaching a wire from the ground to the top of a flagpole to keep it held sturdy, the ground and the wire will form an angle of elevation, the ground being the horizontal line. So let's take a look at example 1. For the annual LHS geometry play, the rapping radicals enter their routine by running up a ramp onto the stage. The ramp is 6 feet long and forms a 56-degree angle with the ground. What is the height of the stage? So we're going to start by drawing out the objects that they're talking about in this scenario. So we definitely have a ramp, right? That's the ramp that the students are going to run up on during the play. And we know that the ramp is 6 feet long. We also know that the ramp forms a 56-degree angle with the ground. So we have a ground, that's our horizontal line here. So the 56-degree angle with the ground and the ramp, that's going to be our angle of elevation. Now we can finish off the picture by drawing our right angle, and they want to know the height of the stage. So the vertical side, the vertical leg of our right triangle is the height of the stage. So we can label that H. If you want to label it X, that works. Any variable will work here. Now that we drew our picture, we labeled all the side lengths and angle measures that we know, and the side length we want to find, we can use a trig equation to set up and solve. So if we look at H, we know that H is opposite angle 56. 6 feet is the hypotenuse, so we're going to use sine here. We have sine of 56 equals H over 6. We're going to multiply by 6 on both sides, so H equals 6 times sine of 56. We're going to plug that into our calculator, and we should get H is about 5.0 feet. They want us to round to the nearest tenth. That's 1 decimal place. So we have 5.0 feet. Remember, with word problems, it's very important that we label our answers with units. So here we need to include feet. Number 2, Susie is flying a kite. The angle of elevation is approximately 47 degrees. If she lets out 60 feet of string, how high is the kite? round to the nearest tenth of a foot. So it's always best to draw any object that they're talking about in the word problem. So let's draw our kite first, right? We have a diagonal string with our kite at the end of it. Susie is down here flying the kite. It says that our angle of elevation is approximately 47 degrees. So remember, our angle of elevation is always formed by a horizontal line and a diagonal. So we know that this angle here is our angle of elevation, which is 47 degrees. It says she lets out 60 feet of string. So the kite string is 60 feet long. And they want us to find the height, how high the kite is. So H will be our vertical leg. Now that we have labeled all of our known side lengths and angles, we can solve for the height of the kite. We know that H is opposite of 47 and 60 is the hypotenuse. So we're going to use sine here. We have sine of 47 equals H over 60. We're going to multiply by 60 on both sides. So we have H equals 60 times sine of 47. We're going to plug that into our calculator. 60 times sine of 47 is about 43.9 feet. Remember, units are very important in word problems. Make sure to include feet in your answer. For number 3, Jason and Evan have to measure the height of a tree for a science experiment. Together, they walk 50 feet away from the base of the tree and look up at the top of the tree. The angle from the ground to the top of the tree is 33 degrees. How tall is the tree? So we're definitely going to have to draw a tree in our picture. It says that Jason and Evan walk 50 feet away from the tree. So Jason and Evan are standing over here now, which is 50 feet away from the tree. The angle from the ground, so the ground is going to be our horizontal side, and the top of the tree, the line of sight to the top of the tree, will be our diagonal side. This angle formed here is our angle of elevation, which is 33 degrees. And we want to know how tall the tree is. So again, we're solving for the height of the tree. Now that we labeled our picture, we have our right triangle. We are going to set up a trig equation and solve. So we know that H is opposite 33 degrees, 50 is adjacent to 33 degrees, so we're going to use tangent here. We have tangent of 33 equals H over 50. We're going to multiply by 50 on both sides. So we have H equals 50 times tan of 33. If we plug that in our calculator, 50 times tan of 33 is about 32.5 feet. Again, units are very important. All right, for numbers 4 through 5, I will help you set up the problem, and then you will have to solve on your own. So for number 4, when leaving school, Michelle and Alice notice that part of Livingston High School is 50 feet tall. They walk away from the building and notice that their angle of elevation to the top of the building is 41 degrees. How far from the base of the building are they? Round to the nearest tenth. All right, so I'm going to draw LHS over here. So we have LHS, and it says that the girls measure the building to be 50 feet tall. So the height of the building there is 50 feet tall. It says that Michelle and Alice walk away from the building. So now the girls are here. And when they look up to the top of the building, their angle of elevation is 41 degrees. So remember, the angle of elevation is always formed by a horizontal line and our diagonal line. So this is our angle of elevation, which is 41 degrees. And they want us to solve for the distance that the girls are from the base of the building. So we're going to solve for x here. Now that our picture is set up, you can go ahead and set up your equation and solve. For number 5, we have a boat is in a lake that is 200 feet deep when the captain lets out the anchor. If the captain lets out 275 feet of chain, what is the angle formed with the chain and the bottom of the lake? Round to the nearest degree. All right, so we have a boat here that's on a lake, and the lake is 200 feet deep where the boat is. The captain is going to let out the anchor chain. Remember, when a captain lets out the chain, it's not going to go straight down to the bottom of the lake. It will go down on a diagonal because of the current in the lake. So he lets out 275 feet of chain. We can form our right angle now, our right triangle. And it wants what angle is formed with the chain and the bottom of the lake. So they're asking for the angle of elevation. The angle of elevation is always formed from a horizontal line, which in this case is the ground, the bottom of the lake. And our diagonal line is the chain. So they want to know our angle of elevation. Remember, when we're solving for an angle using trig, we have to use inverse trig. So you're going to set up your equation and you're going to solve for x. Last one, we have a 14-foot ladder is used to scale a 13-foot wall. At what angle of elevation must the ladder be situated in order to reach the top of the wall? All right, so we have a wall which is 13 feet tall, and we have a ladder that is propped up against the wall, and our ladder is 14 feet long. After forming our right triangle, we want to find at what angle of elevation must the ladder be situated in order to reach the top. So remember, the angle of elevation is always between our horizontal line and our diagonal. So we will be solving for this angle here. This is our angle of elevation. Remember, when we're solving for a missing angle, we have to use inverse trig. So now you can set up your equation and solve.